Hi guys, nice to meet you. I'm Edith. I'm the founder and the CEO of Solo.io. And what we're trying to do in Solo.io is basically focus on a problem that we believe is one of the biggest ones that exists today in the market, is the ability to kind of like migrate and meshing the environment of the monolith, microservices, and serverless together. So we have we're a big player in the open source community, so you can see a lot of our product out, and I will kind of like drill to some of them and also talk a little bit about our enterprise edition. So, okay, so let's first phrase the problem. So this is the problem that I see today in the market. So most of the enterprise today are running monolithic application. That's where the world, this is, you know, if you're looking at the core business application, most likely they're running on monolithic, even sometimes mainframe, right? And in order to manage that, as you all know, you probably need to use something like Terraform and Ansible or Puppet or Chef to kind of like maintain that. And then you need somehow to monitor it. And for that, you will need to use some APM product, right, to kind of like collect the metrics and understand what's going on. Then you probably want to get some logs, right, some insights for troubleshooting. So we'll use something like Splunk. And then the architecture itself of monolithic today, it's what's called SOA, which is service-oriented architecture. But we all see Kelsey Atwater on the KubeCon stage talking and pitching that we all need to move to microservice. And he's right? The velocity there is much faster. So let's see what does it mean, right? So we probably will use some Kubernetes distro. This is most likely what we're going to use. And then if we're actually using Kubernetes, we probably should change our system to have metrics in a higher scale, because now everything is much higher scale, right? So we use something like Prometheus, for instance. And then you probably need to have changing also your logging system, because guess what? Now you need transactional logging, because all your spread of the application is totally spread right now between different microservices, because everything right now is distributed. And then you will use architecture of microservices, which I guess everybody already familiar with. But there's also serverless, and this is kind of like a very interesting trend. It was pushing a lot by the cloud provider, and for good reason, because it makes a lot of sense to run it in the cloud. There's two advantages for it. The first one is the economic one, right? I mean, you're paying for only what you're actually running, which is really, really useful. And the other one is the fact that it can easily glue your services of the cloud provider without actually writing a lot of code. So that's actually really, really useful. But again, in my opinion, it's more useful on the cloud. So if you want to run, you're most likely going to run in the cloud. That's what I gave a Lambda as an example here, because most likely, that's the most mature one. So we use something like Lambda, and therefore you will need to use different system to actually monitor it. So guess what? You will use the cloud provider one. So we'll use the CloudWatch in that case, because it's AWS, and you will use X-Ray for actually getting the logs. And everything will be event-driven now, right? Because this is serverless. This is all the reason to use Lambda and serverless. So now me as a customer who learn of all of this, and I coming to that kind of conference and actually hearing about how everything is awesome, my question is, how am I going to leverage all of this? So let's see what the customer options are. So the first option is just not to do anything. That's too hard. My monolithic is working. Let's just keep it the way it is. I don't need to learn anything new. The problem with this approach is that if your competitor actually move, you just lost the market, right? Because their velocity will be much, much, much faster. So it's not a great solution. So what a lot of other enterprises doing, they basically say, don't worry about it, we will hire killer engineers. And those engineers are going to create the new team. They're going to run only in Kubernetes and serverless. They're going to do crazy stuff. And everything that is greenfield is going to run there, which is fantastic, but you didn't solve any problem. You know why? Because your core monolithic application are still running on the monolithic, which means that you still not moving fast enough. So maybe the supportive application is running faster, but you still have the monolithic logic in a monolithic, which means that your velocity is not much higher. Okay, so that brings us to the third solution. And the third solution is just the big bang, right? I'm going to take everything that exists, every business logic that exists in my monolithic application, and rewrote it in microservices. And this is, good luck, because this is a really big problem. Usually those monolithic applications are really tangled and hard to kind of like spread around. And even if you manage to do that, it probably will take you between a year and 2 years. And guess what? All this time, you didn't get one new feature. And to be fair to the customers, probably will not appreciate that. It's kind of like I'm renovating the room, but I only changing the piping. Who cares? I mean, I didn't get anything in the end of the day. So that's, again, it's kind of like a problematic approach. So the question is, what is the right approach? Because there is, right, people moving all the time. And in my opinion, the best approach is what Lyft did and Twitter did, which they did a really, really good movement. Basically what they did, they managed a way to kind of like take the monolithic application, and everything that they had into this monolithic application will be written by microservices and serverless, and somehow will glue together as one application. And then in your free time, when you have the time to actually learn the new technology, you will start ripping up and kind of like migrate pieces by pieces. And when I looked at this, I said to myself, what is the best approach to actually do that? What is the best approach to kind of like allow this kind of migration? And what I tried to figure out is what is the smallest unit of compute to actually share between all of them? And in my opinion, it is function, right? If you think about it, what is basically serverless? It's an API call that calls some API and basically run a piece of code. If you think about it, it's not that different if you think about it from microservices, right? I mean, microservices is also an API that basically, it's an API that you can exploit and run some piece of code. Same thing with monolithic. So assuming that I actually managed to convince you that this is the best way to approach, if I actually manage to break, and I'm not really breaking, right? I'm just basically discovering and routing to every function that exists in my infrastructure, I can do something like that. And I'm calling it hybrid application, but it can be composite application or whatever name you want. But in the end of the day, it's to run an application that has different type of architecture running. Does that make any sense? Okay, cool. So, of course, this is also help you with money, right? I mean, we all care about money. And in the end of the day, it's much more expensive to kind of like develop and maintain a monolithic application. It's much cheaper when you're going to the other one. So actually, if you kind of like taking your application and is starting adding new technology to it, you're reducing the amount of the cost that it's actually cost, which I think everybody will appreciate. Okay, so let's see some demos. Okay. Okay, so you can all see that, right? Okay. So this is a monolithic application. This is not actually my monolithic application. This is actually written by Pivotal, and I can show you actually the code here. It's basically a regular Spring application. It's the hello world for the Spring. And it's written, and it's great. And we went and deployed that, and it's working. It's written in Java. You can actually see that everything is working, and we're really happy. But here's the thing. I have a new engineer in my team, and I really wanted to add a new column to this page. In order for me to do that, what does it mean that this new engineer needs to do? The first thing that you need to do is to learn the monolithic application. The second thing, you need to add the functionality, then test it, regression test that it didn't break anything else, and then deploy a monolithic application. Quite a lot for only just show one column. So here's what I did. Instead of it, I basically wrote a microservices in Go that's going directly to the database and just bringing everything that you need from there and represent it. So now what we're going to do, we're going to go to Gloo, right? Gloo is because we're gluing the environment, so this is basically the product. And what you will see is that when I'm actually getting here, I can log in. And what you see is that what it's open you is actually the OpenShift login. And the reason is because you're most likely running some Kubernetes distro or anything else, and we don't want to invent the wheel, so we kind of like piggyback on you. If you will log in with your credential to OpenShift, we already know what you allow and not allowed to do. So let's just log in real quick. I'm logging in as admin, and I'm sorry I don't remember the password by heart. So now when I log in, I'm getting here. So what is this? This is the catalog, right? So basically, one of the biggest thing and the most important thing, as I said, is discover it. Because in the end of the day, if I discover everything and I'm able to route to everything, I kind of broke it. So let's see what I have here. So what you can see here is that I found a lot of Lambda function running, right? And we can actually go and open it and see, where it's coming from. It's from the east, and so on. We can also see that I have some services that I discover here. And this is a Swagger one. So basically, not only that we discover the service that's running, we're also discovering the function based on if we're looking at Swagger or gRPC or GraphQL. So you can see that I find some of them. You can see that I found some gRPC services function that's running. And I also have all the services from Kubernetes. So that's pretty simple. And as you can see, I already created a route, and this route going all to the monolithic application. So everything going to the monolithic application. Now the only thing that we're going to do, so basically going to add a route. So if we're going back to the catalog, you can see that I actually have a search here, and we will look for the pet clinic. Pet clinic is basically, this is the monolithic application, and this is the Go microservice that I wrote. So what we're going to do, we're going to come here and say, please add to the default application that I created, that every time that someone is going to vet, right, as a prefix, I want you to go and basically start this, and we will submit it. So now what will happen if we'll go back to the route, you will see that I have 2 routes, right? It's great, it's fantastic. But when we go here, you will see that nothing will change if I will delete. And the reason is because I never sorted it. And the way, I don't know if you know how proxy is working, but the way it's working is basically, everything will be fall on the first bucket, which is everything. So that will not going to happen. So the only thing that we're going to do, we're basically going to sort it. We're just going to drop it up. So right now, if we will get first to the vet, it will go there. And let's see that it's actually working. So I'm coming here, and now when I refresh that, what? Did they do the spelling problem? Oh no, sorry guys, it's not going to work, so let me do it again. Good catch. So default, now we'll write it right. But it means that it's working, right? Because otherwise, and now I'm doing this, and I'm going to bring here. And now it should work. If it didn't just kill everything. And I'm going to bring it back again, and now it should work. Sorry about that. Yes, right? So this is Go microservices. So basically, everything in my application is going to the monolithic application, right? And you see it's still Java, everything is good. And when I'm going to the vets, it will go to the Go microservices. And what you can see is that, so that's already kind of like an hybrid application, right? And now what we're going to do, we're going to go to contact, and we see the contact is not working as well. So I can go to my engineer and ask for him to fix it. Or what I can do is go back to Gloo and basically say to Gloo, please add another route. And what I want you to do, what I didn't show you is that I also have a Lambda function, right? So what I'm going to do is I'm going to add there a function of Node.js Lambda instead of it. So what we're going to do, we're going to find this function, just put it here, add. I want you to add it to the default every time that someone doing /contact. I want you to go there, go to the AWS upstream. Again, we're discovering it all, and I want the contact form tree to get executed. And what will happen is that it will return me a JSON, because this is what Lambda is actually returning. So we created a transformation filter. So we're going to translate it to an HTML, because I want to show you that in the browser. And now I have 3 routes. Again, in order to make it actually work, I need to sort it, right? So now contact is going up, and now what will happen is that this is a Java application, this is a Go microservices, and what we will see here is a Node.js function. So basically, that's exactly what it is, right? An hybrid application. We can also go and see that we're also getting a lot of the stack, which I think is very interesting. So you can see the stacks of the overall system. You can see the Gloo itself to make sure that it's healthy. And then you can see the application itself stack of what's happening with everything that's running on your infrastructure. Okay, so this is basically a very simple way to kind of like migrate application, glue them together, and make sure that they are moving. So let's go back to the presentation and kind of like understand what we just did. Any question, by the way? Not yet, right? Cool. Okay. So basically what we did, we abstract the network, right? This is basically what we did. We abstract the network. This is also what's happening today with service mesh. If we own the network, we can actually have a central place that you can manage your security, your observability, your traffic, right? It's really, really simple. The other thing that was really important for us is because we want to do everything on the function level, because we believe that when you're migrating piece of your monolithic applications, would be easier to do that if it's a small piece of the application, so we want to make sure that it's a function. We also extend the proxy to basically route on the function level, which means that you can do everything that you're doing with regular proxy like Envoy on the function level, canary deployment, security, and so on. So you can actually give a different parameter. We're using Envoy as the control plane right now. So Envoy, that's basically the reason we chose it, is because that was the main use case for Envoy in the first place, to help actually Lyft and Twitter to move from monolithic to microservices. And we extended it quite a lot by writing some filter in C++. Besides that, our control plane is written in Go. So I'll explain you why I believe that this is by far the best thing that exists out there and why I believe that it's special. So first of all, we're using everything that's related to all the trending and the new technology in the open source community. So we're using GraphQL and gRPC and OpenTracing and Swagger and NAT and Nginx and when everything is open source and we kind of like relying on this, and that means that when the community will make it better, we will get it for free, and I think this is really, really powerful. The second thing that we are doing is that our architecture is really, really pluggable, and I think this is really, really key to it. Basically, what we're doing, we are watching. We are watching the upstream that I show you, basically the discovery system that we have that it's really, really strong. We actually look watching the security, so something like Vault or Kubernetes secret, and we're also watching your configuration. And once one of those change, we're getting this data. Basically, we don't know anything about it. Gloo itself is pretty dumb. It doesn't know anything. What it does know is to kind of like send it to the plugin system of it, which basically know how to take and translate to the Envoy language, and Envoy actually is taking the snapshot when we're doing this. So that's allowing us to go very fast. We can add a lot of feature, right? Really, really quick. When they announced, say, Knative for serverless, we were, out there 3 days after it with a solution. The other thing is that what is important is that eventually that everything will be supported as an enterprise feature. So everything that you saw me doing right now in the UI is not going directly to Gloo, because that's too dangerous. You saw how quick this changed the network. It's going first and basically checking your configuration to a GitHub. And only after it's approved, we're watching it, and then we're going to set it. So you basically have an audit for everything that's happening. You can approve, you can use diff, you can actually take all the leverage rollbacks and so on that GitHub is giving you. We're doing it multi-cloud. It's giving you a lot of security features, very easy on board. We're discovering everything really, really quick and so on. So it's giving you a lot of the power of the enterprise, which I don't believe it exists today in every on the Envoy distro. But as I said, in order to actually work with that dynamic environment, you need to make sure that you can actually discover everything, and it should discover for you. It shouldn't be you that discovering it, because stuff is changing really, really quick. So here's how it's working for us. We're basically discovering everything that exists on the infrastructure level. If you're using Terraform, we also know what is the port that your application is served on. And then we're moving to the services, and we're checking to see if you actually have any services on the next layer. And if we find it the services, we know the information. But even that, we didn't stop. We basically go into those services, and we're trying to figure it out if you're running it as Swagger, gRPC, or GraphQL. If you do, now we know also the signature of the function. And it's really, really powerful, specifically if you're looking at security, because if I know what the function that actually is, so how my function look, and I'm getting a request, I can make sure that it's actually not doing anything very nasty, right? Some DDoS attack or bot and so on. So that's really, really powerful. That's giving us a lot of functionality. And besides that, we're also going to all the serverless environment that exists out there and basically stacking the information from there. So basically, now you know everything. You know everything, we can be smart about it. We also really don't want you to change anything. The onboard have to be seamless. And in order to do that, what we're doing, we're basically using everything that you're using already. So if you're using Nomad, Kubernetes, OpenShift, any VM or Docker, it's basically going to run on it, right? It's really, really simple microservice environment that will run on whatever you have. The second thing that we're doing, we need to save your persistent, because Gloo is stateless. And in order to do that, we're going to use, again, what you're using already for your environment. So Consul, for instance, is a storage. It's not only for the discovery, it's also a very good storage key value store, right? Kubernetes for CRDs, for instance, if you're familiar with, in YAML file, in memory, etcd, whatever you basically want, we can support, because we have a very nice abstraction. And the last thing is, in terms of security, as I mentioned, we're basically supporting Vault and supporting Kubernetes secret. So that's allowed us to do this, which is really, really cool, right? Basically take an application and basically abstract the client from the server and kind of like glue them together. But what it's not giving us to do is the ability to create a relationship between those services. And that's really interesting, because if you think about what I did, every time that I went, based on the route, I went to a different microservices or services on the backend, but I never interact between them. And that could be very powerful. That's why we created Sqoop. And what Sqoop is, basically when we looked at Gloo, we noticed that there are a lot of the stuff in the Gloo that we're already supporting on top of Envoy is basically familiar to what people are trying to do with GraphQL. And with GraphQL, you need to do quite a lot in order to make everything working. You need to write a resolver and metrics and logging and make sure to tie everything, and you're writing code, basically. But think about it. If we actually have all these things in Gloo that are actually capable of routing, and then what we're going to do, we're going to basically make the resolver always going to Gloo. Now we can kind of like configure it. Everything can be configurable, which means that you're getting all your environment GraphQL, and you can query whatever you want without actually any code at all. And this is what Sqooping is. I will show you real quick how it looks in the environment. So, okay. So what we're going to do is this. I have this application that I created. It's called Thingamabobble. I don't know, my kid's saying it all the time, so I thought it's a good name. So basically what it is, it's basically an organization, and there is two divisions in this organization. One division is the human resource, the HR. They know, performance of people, right? Performance of people working on the organization. There is another group, which is the engineering. They know project, right? You're clicking this, you're getting the project that exists, how much it costs, what is the value, and so on. And the last one is basically you have a finance. And this is the most interesting thing because you're getting salaries of the employment. This is great. This is all, very simple. But when we look into Gloo, we will discover that this actually, it's a 3 different applications. The first one that I show with the finance, it's basically a Lambda, what gets salary. It's basically just beaming the salary of every employee that I'm giving it. The second one, it's basically the engineering. And in the engineering, I have basically a Swagger service that's basically giving me all the projects that exist. And the last one is basically a gRPC service that actually giving me all the performance. So it's 3 different, totally different architecture, different everything. But what I think will be really cool if we'll be able to actually merge them together, ask questions. Give me the people who are running on this project has a very good performance, but their salary is less than 70K or something like that. And that's the beautiful of exactly what Gloo is giving you. So if you can route to a function, you can route to a function to a service, and you can run also to a GraphQL service that you're creating here. So what you will see is basically you have a schema here in Gloo that you're basically giving me a schema. And the schema basically telling me how this service is supposed to interact between. And once you're giving me, basically what I see is that every function, every resolver, every field that you wanted to answer will appear here. So you can see, and then, like for instance, you need to do the first name. When I will click at it, I will be able to choose the value from everything that I want, right? And this is the beauty of it. So now it will be very simple, and I can actually get a GraphQL and merge everything that I want in my environment. Go to the report and do the same thing. So basically right now, I just basically merge all the environment, and I can get the data between those microservices and this environment. And that's what Sqoop is giving us. But again, it's part of the Gloo Enterprise Edition. Hopefully that was useful. So now what we're going to do, to make sense, we will talk a little bit about Consul Connect. So we was the first one who actually partnered with HashiCorp and helped with this Envoy integration with Consul Connect. So I want to verify to explain how it's working, what is the difference between service mesh and regular one, and an API server, and that's what we're going to do right now. So the difference is basically between the north and south traffic and the west and east traffic. Basically, when something is coming to the cluster, you need to go through an API gateway or something like that. And basically, everything that is going north south is going to be managed by something like Gloo or any other API gateway. Once it's in the cluster, if they want to talk between the microservices, they will do that with something like Consul Connect. So basically, that will be in charge for the inbound, the east-west traffic versus something like Gloo will be in the entry to the cluster. Hopefully, it's making any sense. And the use case is really different because when you're actually talking about service mesh, there is 3 features that we're trying to leverage. One of them is the security, the other one is the observability, and the third one is the routing inside the cluster. When you're talking about something that's coming outside the cluster, now you need to look a little bit differently. And this is where Gloo is coming and help you to migrate this environment. It's giving you to do everything that is coming outside the cluster with transformation filter and a lot of other power, and it's giving you the GraphQL as well. I think it's really, really powerful. Okay, but we didn't want to stop with this, so we did one more thing. And this thing is, we understand that most of the people who are actually running proxies today, they're not running only Envoy. They're running, actually, most of them probably Nginx, or maybe they're running API gateway of Amazon. And we wanted to make sure that we're helping all of them. We don't want to force you to move to Envoy. So the experience will look something like that. Basically, when we're coming to your infrastructure, we're sucking the information from every basically Nginx or any proxy that you have, every API gateway that you have, and bringing it to Gloo. So now we know everything they're talking. HA proxy is another one that we're supporting. So basically, we're bringing all the information to Gloo. And then what you can do is basically make a choice. Either we continue managing it for you, or you want to migrate, just change it, and we will move it to Envoy. Or maybe what you want to do, even something more powerful, which is put Envoy next to the other proxy, something like Nginx or HA proxy, for instance, because Nginx is giving you stuff that Envoy is not giving you, like static file serving and so on. So now you can actually leverage them all, and Gloo will manage all of this for you. So I think this is really, really useful. OK, so I think I have a little bit more time. So let's talk about how to debug all of this. So I think all of you probably will realize that this is what's going on when you're moving to microservices, right? When you're moving to microservices, you're in hell, right? So now you need to figure out what's going on. And this is a big problem that everybody have there. Specifically right now, if we're actually going to kind of like bind you into this hybrid approach, which is you're not running only microservices, you're running something else, the question is how to debug it. So I want to show you a quick demo. It's called Squash. It's an open source project which I found really, really useful. Just need to run it on AWS, so it will take a sec. OK, so in a second it will start for us. Any question until now? No? So either I lost you totally, or very clear. OK. So in a second, what you will see is that I have an application called, it's a very simple calculator. And it's built basically from two microservices. One of them reading in Go, and the other one is reading in Java. It's a really simple one. Just 1 second. It will start once the pod will go up. So in a second, this will happen. And here is the thing. In a second, when it will start, you will see that there is some bug in this. Here you go. OK. So what you can see is that basically it is a very simple calculator. There's nothing really into it. And what you can see is that I can give two numbers to it, like 99, for instance, and 11. And when I'm actually getting the result, it's not working, right? It's not working. It's not the right result. So what people usually doing in order to discover what's going on, specifically when they're running microservices, they troubleshoot, right? They plug. There is no other option, so they actually start to print. So we think that we can do that better. So here's how this microservices, this calculator is actually working. So there's service number 1. It's reading in Go. It's right now, I'm showing it in Visual Studio Code. But basically, it's basically serving the HTML. That's all it's doing. It's getting the 2 parameter. And what it's trying to do is to move it basically to the Java application that I will open here, the microservices that basically getting these 2 values and either add or subtract, return the value to the Go microservices and showing it the screen. So here's what we did. When you're actually going, hopefully you can see that, but when you're actually going to the application, to the Visual Studio, and you start writing Squash, you're getting commands. And one of the commands that you will get is Debug Container. So I will click this one. What it will bring me is going to my Kubernetes and basically give me all the pod that's running in the Kubernetes environment. So I'm going to choose the first one because this is service 1. Then it tells me, look, in this pod, you have 1 microservices. Do you want to debug it? And the answer is yes. And then he said to me, which debugger do you feel like attaching to it? And this is reading in Go, so we will attach the DLV. So in a second, what's happening? This is running on AWS. And what you will see in a second, that I basically start to debug my microservices. Now we'll do the same thing exactly with the other microservices, reading in Java. This is IntelliJ. And I'm going to do Squash and Debug Container. And I have a problem. Wait. So I will not be able to show you all the demo. That's because I didn't context switch it well. But what I can show you here is that once I will click this one again, I'm basically live debugging it. And I can just, step into, I see the value, I can change them on runtime and so on. And this is the way you should actually treat when you're actually debugging your microservices. Just go to the console and be able to attach a debugger. Hopefully that makes sense. Unfortunately, I cannot show you on the other one. I need to restart my computer for that. Any question?
Yeah.
Yeah.
Does Gloo help at all with stubbing services or maybe something like contract-based validation?
Yes, definitely. So one of the things that I didn't show you because I didn't have a lot of time is that what we did, we basically took the proxy and enhanced it quite a lot. We wrote a lot of filters. And what the filter is doing is that basically on the request by giving you a lot of validation, making sure that this is, I can't see anything, it's over. So basically we enhance it to do exactly what you described. I can't see that, show it in a little bit demo, but I can show you that after it. But yeah, the answer is yes. Yeah. Any other question? No? So I think I will return you some time from your life. Thanks so much.